Hello. So in this video, we're going to be doing some inequality verification. So typically, if we want to know if an inequality is valid at a certain point, the easiest way, like there are lots of ways we could graph it and we could, do some stuff. But honestly, the easiest way is to just compute both sides of that and see if the inequality is true. So that's all we're going to do. So here, right, I have my left-hand side. So I have the right, negative 7x plus 10 all cubed minus 4x plus 10. But I want to know at x equals 1, right, whether or not this thing is going to be valid, like that thing is bigger, right, than that. So I'm just going to plug in 1. So minus 7, 1, plus 10 all cubed minus 4 times 1 plus 10. And I want to know, right, so it's best not to write the symbol unless you know already it's true, like mathematically that's making a statement if I just said greater than blah. There's a couple ways of doing this. One, I could put the greater than with a question mark over it, saying like, I don't know if that's true, right? That's the signal to the reader. If I didn't do that, if I just put greater than, I'm asserting that it is true. So that's minus 14 times 1 minus 2 squared minus 9 times square root of 2 times 1 plus 1 plus 2. Okay, so the question is this inequality true? All right, so let's go. So negative 7 times 1, that's negative 7 plus 10, so that's going to be 3 inside, minus 4 plus 10. And again, I don't know if this is greater than or not. Here I'm going to have 1 minus 2, so that's negative 2, negative 1, so I'm going to have negative 14 times negative 1 squared minus 9 times square root of 2 times 1 is 2 plus 1 is 3. And then that's in square root, and then I have plus 2. Okay. All right, keep going here. So 3 cubed, that's 27, and that's going to be a 6. So I'm going to have 27 plus 6. Still not sure. So negative 1 squared is just positive 1 times negative 14. That's negative 14. Minus 9. Square root of 3 is some annoying thing, so I'm just going to leave it like that. Plus 2. So on the left side, I have 33. Question mark. Over here, I have negative 14 plus 2, so that's negative 12, minus 9 root 3. Now, at this point, you might be wondering, like, okay, we need to get a calculator to figure out what root 3 is so we can compute this thing, right? Root 3 is like 1.71 or whatever, and then I can multiply by that 9, by negative 9, right? Take that value and combine it with the negative 12, dot, 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 dot. Way too much work. You don't need to do that at all. Because all we want to know is whether this inequality is true. We don't actually need to know what the sides equal, right? And over here, I have 33, which you'll note, 33 is definitely bigger than 0, right? Over here, we have negative 12, and then we're subtracting off 9 times root 3. So whatever that is, right, whatever 9, so if I think of this as plus negative, maybe that'll make it a little bit easier. If I think of negative 9 times root 3 is a positive thing. Negative 9 is negative. So those two together are negative. And then adding that to another negative, this thing, whatever it is definitely smaller than 0, right? Because this is negative, and then I'm subtracting more stuff off of it. So it's even more negative. So it's less than 0. This is bigger than 0. That means it worked, right? So I don't actually have to calculate stuff as long as I can sort of justify why that would work, right? As long as I can look at it and be like, this is negative 12, that's negative, a bunch of other stuff, putting that together is still negative. This thing's positive, I'm good. If this were a plus, then I might be like, now it's a little bit harder because I have, right, negative 12, but then I'm adding some positive thing and I don't know where that's gonna land exactly. But even then I could do some, shenanigans to sort of get out of actually computing the value. Something like square root of 3, that's less than let's say 2, right? Because square root of 4 is 2. So this is sort of less than, say, negative, right? If this were positive, it would be less than 18. That would still only be 6. That would still work, right? Like, so there are some tricks to play that if you can use to get out of doing computation. But this is sort of the classic, right? Where I have positive, negative, clearly that works. Okay. So that's that. Hello. So in this segment, we are verifying an inequality, right? So the idea is that we have an x value. We want to know, is the left side really that greater than the right side at that x value? So this is sort of, again, there's sort of a bunch of ways we could do this, but really the easiest way is always just to plug in and calculate. I should say almost easiest way. Very specific circumstances, there might be a trick that you could do, but it's not even worth going into because they're basically never happen. Okay, so looking at this then, I'm going to plug in 3. So left side I have -2 times 3 times 3 plus 1 all squared minus 2 times 3 minus 4 all cubed minus 15. Now I want to know if that's greater than this other side. I shouldn't write greater than because that's just sort of assuming it's true, right? I could do the greater than with a question mark, or I could basically just do these as 2 separate calculations, which is what I'm going to do here. So this is another way we can do it. -9, 5 times 3 minus 8 minus 12. Okay. So now I'm going to calculate, then I'll calculate, and then I'll see if the inequality, if I can justify it. So here I'm going to have -2 times, 3 times 3 is 9, plus 1 is 10, squared, minus 2 times 3 minus 4 is -1, cubed, minus 15. So here I'm going to have -2 times 100, so that's -200, minus, so -1 cubed is -1, times -2 is a +2, minus 15. So putting those together, I get -13 with -200 is -213. Okay, over here, I'm going to get -9 square root of, so 5 times 3 is 15 minus 8. So 15 minus 8 is going to be 7 minus 12. All right. Now, square root of 7, that is an annoying number. Again, I could take out a calculator and do this as a decimal, but I don't actually have to. Here it's a little less straightforward though, because here I have some giant negative. This is negative and another negative, so they're both negative. It's not as simple as saying like one's positive, one's negative. That's easy enough, right? That doesn't really work. What I could try to do though is figure out roughly where this is by sort of looking at the nearest or farthest, sort of nearest in each direction, let's say, that of a square root that I could do, right? So for example, if this were square root of 4, then I would have -9 square root of 4 minus 12. So this would be -18 minus 12 would be -30, right? If that were a 4, which it's not. So that was the sort of next one down that was a nice perfect square that I could do. But I could go up too to the next perfect square, which would be 9. So then I would have -9 square root of 9 minus 12. Seems my marker might be dying a little, sorry. Trying to make this as legible as I can. So the square root of 9 is 3, so that's -9 times 3 minus 12. And that's -27 minus 12 is -39. So that tells me that this value is between -30 and -39. I may not know what it is, but I know it's somewhere between those two. Importantly, both of those are way bigger than -213, right? Because this is way more to the left than that one is. So what that tells me is that this inequality at 3 actually goes sort of that direction, right? And if I look at what I actually wanted, right, I was trying to verify that it went the other direction. So this is not true. Okay. So again, you don't actually have to calculate annoying things like this when you're dealing with inequalities, because the nice thing about inequalities is you don't need exact numbers, you just need to know the relationship. Now, if I had gotten sort of like -200 and -250, it was somewhere between those, then I'd be sort of out of luck because that sort of includes my range. So at that point, I'd actually have to do some decimal calculations, get a calculator or whatever. But here, I didn't have to do that. Okay? So that is that. Hi. So in this video, we are doing a verifying of an inequality, right? So again, lots of ways we could do this, but by a landslide, the easiest way is to just plug in the number that we're interested in as all the x's and see if indeed one side is greater than, less than, equal to, whatever we're trying to check, than the other side. So in this, we want to see if the left is greater than the right. So we're going to check that and see if it worked. Okay. All right. So -2. So I'm going to plug that in for all the x's. So we have 9 times 2 times -2 plus 3 all cubed minus 4 times 9 times -2 minus 19. And I want to know if that's greater than this other thing. So again, I could do the greater than with a question mark or just 2 different computations. So I'm going to do the 2 different ones method. This is 2 times 3 times -2 plus 2 all cubed minus 6 times -2. Okay. So calculate all the way down, calculate all the way down, check which one's bigger. It really is that simple. So here I'm going to have 9 times. So that's 2 times -2 is -4 plus 3. So that's -1 cubed. Minus, so 4 times -2 is -8. So it's going to become a plus 8 minus 19. Here, -1 cubed is -9. Well, -1 cubed is -1 times 9 is -9, just to be clear. 8 minus 19, so that's going to be minus 11. Minus 9 minus 11, that's minus 20. Okay, over here we have 2 times, so 3 times -2 is -6, plus 2 is -4, cubed, minus 6 times -2, that's -12, so that becomes a plus 12. Now here I have -4 cubed, so -4, so 4 cubed, 4 times 4 is 16, times 4 is 64, and the negative cubed stays negative, so this is going to be 2 times -64 plus 12. 2 times -64 is going to be -128 plus 12. And then putting those together, -128 plus 12 is -116. I mean, honestly, I could have stopped like here because that's very clear that, right, the relationship to -20, but just to go the full way and make sure. Now, -16 is further left than -20, so that means my inequality is going this way, right? The -20 is the bigger thing because it's further to the right, which is indeed what I wanted, right? I wanted to have the left side be the bigger side. It is at that value, so I'm all set, right? Note that I'm not verifying the general inequality. I'm verifying the inequality at a specific x values. This may not always be true, but it is true at the particular x value I wanted. Okay, so that's that.